0 o'clock to 0:15. Have you ever looked up at the night sky and felt a sense of endlessness? A sea of stars, galaxies, and nebulae stretching out forever? It feels infinite, boundless, a cosmic ocean without a shore. But what if I told you there's a wall, boundary that we can't see past, no matter how powerful our telescopes become? 0:15 to 0:30. This isn't a physical wall, but an edge to our reality, a horizon of space and time. It's called the observable universe, and it's the only part of the cosmos we will ever be able to interact with. So what is this cosmic bubble we live in? Why does it have a limit? And the biggest question of all, what lies beyond? 0:32, 1 o'clock today, we're embarking on a journey to the very edge of what we can see, to the boundary of our known existence. This is a story about the ultimate limit, a tale of light, time, and the vast, silent cosmos that waits just beyond our reach. Stick around, because what we're about to explore will change the way you see the universe forever. 1 o'clock to 1:45, to understand the edge, we first need to understand what we're looking at. Every time you gaze at the stars, you're not just looking across space, you're looking back in time. The light from our sun takes about 8 minutes to reach us. That means if the sun were to suddenly vanish, we wouldn't know for 8 whole minutes. The light from our nearest star system, Alpha Centauri, takes over 4 years to get here. We see it as it was 4 years in the past. 1:45 to 2:30 now, scale that up. The Andromeda Galaxy, our closest major galactic neighbor, is 2.5 million light-years away. The light we see from it tonight started its journey when early humans were just beginning to walk the Earth. Every galaxy we observe is a snapshot from the past. The farther we look, the deeper into history we peer. This is the fundamental principle of cosmology. Looking out is looking back. 2:30 to 3:15. So, how far back can we go? Our universe isn't infinitely old. The best evidence we have points to a beginning, an event we call the Big Bang, which happened approximately 13.8 billion years ago. In that moment, the universe was incredibly hot and dense, and it began to expand and cool. Since then, light has been streaming out from every point in the cosmos, traveling in all directions. 3:15 to 4 o'clock, the maximum distance light could have traveled since the beginning of time is, you guessed it, about 13.8 billion light-years. This creates a conceptual sphere around us, with Earth at the center. Can't see anything whose light hasn't had enough time to reach us. This sphere is the observable universe. It's not the entire asterisk universe, just the part of it we can, in principle, observe. It's 4 o'clock to 4:45, but here's where it gets mind-bending. You might think, okay, so the observable universe is 13.8 billion light-years in radius, right? Not quite. While the light was traveling, the universe itself was expanding. The space between us and that distant object has stretched dramatically. That distant galaxy that emitted its light 13.8 billion years ago is now much, much farther away. 4:45 to 5:30, when we account for this cosmic expansion, scientists calculate that the actual distance to the edge of the observable universe today is about 46.5 billion light-years. This means the observable universe is a sphere with a diameter of roughly 93 billion light-years. Inside this colossal bubble is every star, every galaxy, every quasar, everything we have ever seen or ever will see. 5:30 to 6:15, so let's picture this. We're on Earth, at the center of our personal observable universe. An alien in a galaxy 10 billion light-years away is also at the center of their own observable universe. Their bubble overlaps with ours, but they can see parts of the cosmos that are forever hidden from us, and we can see parts that are hidden from them. Everyone, everywhere, has their own horizon. 6:15 to 7 o'clock, what do we actually see when we look towards this edge? We see the universe's baby picture. As we look farther out, we see younger and younger galaxies. Go far enough, and we reach a time before galaxies or even stars had formed. This is the cosmic dark ages. Beyond that, we hit a wall of light, the cosmic microwave background, or CMB. 7 o'clock to 7:45, the CMB is the oldest light in the universe, an afterglow from the Big Bang itself. It was emitted when the universe was just 380,000 years old. Before that time, the universe was a super hot, dense plasma, opaque to light. So the CMB is our ultimate observational limit. It's a faint, uniform glow of microwave radiation coming from every direction in the sky, marking the boundary of what our telescopes can physically detect. 7:45 to 8:30, this brings us to the ultimate question. What lies beyond the edge of the observable universe? The simple, and perhaps frustrating answer is, we don't know for sure. There's no scientific reason to believe the universe just stops at our horizon. The laws of physics don't suddenly break down. The most straightforward assumption is that it's just more of the same. 8:30 to 9:15, more galaxies, more stars, more cosmic voids, stretching on and on. Based on the smooth, uniform nature of the universe we see, cosmologists believe the total universe is vastly larger than our observable part. How much larger?
Nice.
Some estimates suggest it could be hundreds, thousands, or even trillions of times bigger. It might even be genuinely infinite. 9:15 to 10 o'clock, if the universe is infinite, then the implications are staggering. In an infinite space, every possible configuration of matter must exist somewhere. That means there could be another you, living on another Earth, making a slightly different choice right now. There could be infinite versions of our history playing out in infinite ways across an unending cosmos. This is the patchwork multiverse theory, and it's a direct consequence of an infinite universe. 10 o'clock to 10:45. But what if the universe isn't just more of the same? Other, more exotic theories propose that the physics beyond our horizon could be completely different. Our universe might be just one bubble in a much larger multiverse. In this scenario, other bubble universes could have formed from their own big bangs, potentially with different physical laws, different constants, and maybe even different dimensions. 10:45 to 11:30. This is the idea of eternal inflation. The process of cosmic expansion that created our universe might be happening constantly, spawning new universes like bubbles in a boiling pot. Unfortunately, since these other universes are outside our observable horizon and expanding away from us faster than the speed of light, we have no way to test this idea directly. It remains in the realm of theoretical physics and philosophy. 11:30 to 12:15. The edge of the observable universe isn't just a physical limit, it's a philosophical one. It forces us to confront our own smallness. We live on a tiny planet, in a typical solar system, in an average galaxy, all tucked away in one small, observable patch of a potentially infinite cosmos. Everything we've ever known, everyone who has ever lived, exists within this bubble. 12:15 to 13 o'clock, beyond that bubble is a vastness we can only imagine. An unseen realm where light from its creation hasn't had time to reach us yet, and due to the accelerating expansion of the universe, never will.
Ow.
Those distant galaxies beyond the horizon are not just unseeable, they are forever disconnected from us. We are, in a very real sense, on a cosmic island. 13 o'clock to 13:45. But this limitation isn't a cause for despair. It's a source of wonder. It gives context to our existence. The fact that we, a species on a small rocky world, can even comprehend this boundary that we can measure the afterglow of creation and calculate the size of. Our cosmic window is, perhaps, the most remarkable thing of all. We are a part of the universe that has become self-aware. 13:45 to 14:15, our knowledge has its own horizon, just like the cosmos. But with every new discovery, every new telescope, and every brilliant mind that dares to ask what if, we push that horizon back little by little. We may never see what lies beyond the ultimate edge, but the quest to understand it is what drives science, exploration, and our very humanity. 14:15 to 15 o'clock, the universe we can see is 93 billion light-years across. It's filled with 2 trillion galaxies and more stars than grains of sand on all the beaches of Earth. And that's just the part we can see. It's a humbling, awe-inspiring thought. So next time you look up at the night sky, remember the invisible boundary that surrounds you, and wonder about the infinite possibilities that lie just beyond the darkness. Have you ever looked up at the night sky and wondered, how far does it all go? Is there an edge to the universe? It's a question that has captivated thinkers for centuries. While the answer is more complex than a simple yes or no, it takes us on an incredible journey to the very beginning of time and space. So, what is the edge of the universe, and what lies beyond it? Let's find out. To understand why the universe even seems to have an edge, we have to rewind the clock. Way back, about 13.8 billion years to be precise. This is the moment we call the Big Bang. Now, common misconception is that the Big Bang was an explosion in asterisk space, like a firework bursting into an empty room. But that's not quite right. It was the birth of space itself, time, and all the matter and energy we see today. Imagine an infinitely dense, incredibly hot point. That was our universe. Then, in an instant, it began to expand. Not into anything, but everywhere at once. Think of it like the surface of a balloon being inflated. If you draw two dots on it, as the balloon expands, the dots move away from each other. That's what happened to everything in the early universe. Every point moved away from every other point, as the very fabric of space stretched. As the universe expanded, it cooled down. In the first fractions of a second, the fundamental forces of nature as we know them, gravity, electromagnetism, and the nuclear forces separated from a single, unified force. The universe was a chaotic soup of elementary particles. Within minutes, things had cooled enough for protons and neutrons to start clumping together, forming the first atomic nuclei, mostly hydrogen and helium. But the universe was still a scorching, opaque fog. It was so hot and dense that electrons couldn't settle down with the nuclei. Instead, they zipped around as a plasma, and light particles, called photons, were trapped. A photon could untravel more than a tiny distance before bumping into a charged particle and getting scattered. It was like trying to see through an incredibly dense fog. Then, about 380,000 years after the Big Bang, a monumental event occurred. The universe cooled to about 3,000 degrees Celsius, a temperature cool enough for electrons to be captured by atomic nuclei, forming the first stable neutral atoms. This moment is called recombination, and it changed everything. Suddenly, the universe went from opaque to transparent. With the electrons now bound into atoms, the photons were finally free. They burst forth, streaming unimpeded across the cosmos in all directions. This first light released from the cosmic fog is still traveling today. This ancient light is what we now call the cosmic microwave background, or CMB. Think of the CMB as the last scattering surface. It's the oldest light we can possibly see. When we look at the CMB with our telescopes, we are literally looking at a snapshot of the universe when it was just 380,000 years old. It's the ultimate baby picture of our cosmos. This faint, uniform glow of microwaves fills the entire sky, coming from every direction. It's the afterglow of the Big Bang, stretched out over 13.8 billion years of cosmic expansion from high-energy light into low-energy microwaves. And this ancient wall of light is what defines the edge of our observable universe. So, when we ask what lies beyond the edge of the universe, the answer is not a brick wall or an empty void. What lies beyond is simply a time before the universe was transparent. It's a period in cosmic history when light was trapped in that hot, dense fog. We can't see past the CMB with conventional telescopes because there was no free-traveling light to see. It's like being in a room with no windows. Your view is limited by the walls, but you know the world continues outside. But here's where the story gets even more mind-bending. Our universe is 13.8 billion years old, so you might logically assume that the edge of the observable universe should be 13.8 billion light-years away, right? That's the maximum distance light could have traveled in that time? Well, it's not that simple. The actual distance to the edge of the observable universe that CMB surfaces about 46.5 billion light-years away. That makes the entire observable universe about 93 billion light-years in diameter. How is that possible? How can something be 46.5 billion light-years away if the universe is only 13.8 billion years old? The answer is no, and it lies in the expansion of space itself. Remember our balloon analogy? Let's go back to it. Imagine a tiny ant starting to walk from one dot to another on the surface of the uninflated balloon. Now as the ant walks, you start inflating the balloon. The ant is still walking at its top speed, but the space between the dots is stretching. By the time the ant finishes its journey, the starting point is much farther away than the distance the ant actually walked. That's exactly what happened with the light from the CMB. Those photons began their journey toward us 13.8 billion years ago, from a region of space that was, at the time, much closer. But during their long journey, The fabric of space itself has been expanding and stretching. The space that emitted those photons has been carried away from us and is now a staggering 46.5 billion light-years away. So we're not seeing where that region is now, but where it was when the light left. This boundary, defined by the distance light has had time to reach us, is called the cosmic horizon. It's not a physical edge, but a boundary of information. Anything beyond this horizon is, for now, invisible to us, because its light hasn't had enough time to complete the journey across an expanding universe to reach our telescopes. Now, here's a crucial and humbling point. This observable bubble is unique to us. It's centered on Earth, or more accurately, on the Milky Way galaxy. But this doesn't mean we're at the center of the universe. Far from it. If you were on a distant galaxy, say 10 billion light-years from here, you would have your own observable universe, a 93 billion light-year bubble centered on you. Your bubble would overlap with ours, and we would share a large part of the visible cosmos. But you would see parts of the universe that are beyond our horizon, and we would see parts that are beyond yours. This means the observable universe is not the entire universe, just our local visible patch. The full universe, the whole thing, is almost certainly much, much larger. How much larger? We don't know. It might even be infinite. Our view is fundamentally limited. So, the idea of an edge is really an illusion or horizon created by the finite speed of light and the finite age of the universe. It's a boundary not of space, but of knowledge. Just as ancient sailors gazed at the ocean's horizon, wondering what lay beyond, we modern explorers gaze at the cosmic horizon. We stand at the very edge of observable reality, armed with the knowledge that there is almost certainly more universe out there, more galaxies, more stars, perhaps even other forms of life that we simply cannot see. Not yet, anyway. It's a profound thought that our perception of reality is just a small sphere in a potentially endless cosmic ocean. It reminds us that there's always more to discover, more to learn, and that the greatest mysteries might lie just beyond what we can see. Have you ever looked up at the night sky and wondered where it all ends? We stand on a tiny blue dot, peering out into a cosmos so vast it's almost impossible to comprehend. We can see billions of galaxies, each with billions of stars. But there's a limit, a boundary, not a wall, but a veil. This is the edge of the observable universe, and what lies beyond is one of the greatest mysteries of all time. Today, we're venturing into that unknown. Let's explore the mind-bending possibilities that exist just beyond our sight. One of the first questions we have to ask is the universe infinite? Our best measurements suggest that the universe is geometrically flat. Imagine a perfectly flat sheet of paper stretching out forever. If you draw two parallel lines on it, they'll never meet. That's what a flat universe is like on a cosmic scale. And a flat universe often implies an infinite wanan, endless expanse of space, stars, and galaxies. But the concept of infinity makes even physicists a little uncomfortable. It's a mathematical idea that's hard to grasp in reality. It's possible the universe is just unimaginably large, but still finite. Think about the surface of the Earth. You can walk in one direction forever and never fall off the edge, but the Earth is definitely not infinite. Our universe could be like that, but in a higher dimension, a closed but boundless shape. Problem is, we may never know for sure. We can only see as far as light has had time to travel to us since the Big Bang. Beyond that cosmic horizon, the truth remains hidden. But even within the universe, we can theoretically see there's a cruel cosmic trick being played on us. The universe is not just expanding, it's accelerating. A mysterious force we call dark energy is pushing everything apart, faster and faster. Galaxies beyond a certain distance are now moving away from us faster than the speed of light. This isn't breaking Einstein's laws, because it's space itself that's stretching. The consequence: the light from those galaxies, emitted today, will never reach us. It's like trying to swim upstream against a current that's too strong. This creates what's known as a cosmic event horizon. Anything that crosses it is lost to us forever. Right now, most of the galaxies in the universe are already slipping beyond this point of no return. In the far, far future, an observer on Earth would look out and see an almost empty sky, with only our local group of galaxies remaining. Our accessible universe is, in a way, shrinking. The cosmic expansion is acting like a cosmic sensor, hiding most of reality from our view. So what if our universe isn't the only one? This is where we enter the realm of the multiverse, one of the most exciting and speculative ideas in modern physics. The theory of cosmic inflation suggests that in the first fraction of a second after the Big Bang, our universe expanded at an unbelievable rate. Some models of inflation predict that this process didn't happen just once. Instead, it could be happening all the time, creating countless bubble universes, each one potentially with its own unique laws of physics. Imagine an infinite cosmic foam, and our universe is just one tiny bubble. In other bubbles, gravity might be weaker, the speed of light could be different, or perhaps stars and planets never even formed. These other universes would be completely unlike our own. Of course, the multiverse is still a hypothesis. By its very nature, we can't observe these other universes. But the idea doesn't come from science fiction. It arises from our best attempts to understand the origins of our own cosmos. The thought that reality is so much grander than what we see is both humbling and exhilarating. Even if we're living in a single, infinite universe, what if the part we see isn't representative of the whole? Think about looking at a single pixel on a giant screen. You have no idea what the full picture is? You might see a speck of blue, but the complete image could be a portrait, a landscape, or just random static. Similarly, we see a cosmic web of galaxy clusters and massive empty voids. Is this pattern repeated forever? Or is it just one small part of a much larger, stranger structure we can't even imagine? There could be cosmic structures so immense that they stretch far beyond our observational horizon. You might be living in a quiet, ordinary corner of a universe that contains features of unimaginable scale and complexity. Without being able to see the whole picture, we're left to wonder if our little patch of the cosmos is truly typical, or just a cosmic anomaly. This brings us to an even deeper question. Do the laws of physics themselves change out there? We assume the fundamental constants of nature, like the strength of gravity or the charge of an electron, are the same everywhere. But what if they're not? In a multiverse, each bubble universe could have its own set of rules. But even within our own universe, Some theories speculate that these constants might vary over vast distances. Could there be regions of space where light travels at a different speed or where atoms can't hold together? And what about dark matter and dark energy, which make up 95% of our universe? We barely understand what they are. It's entirely possible they behave differently in other cosmic regions, leading to universes with completely different fates. The very fabric of space could be twisted into strange shapes or topologies that we can't detect from our vantage point. We are exploring a frontier not just of space, but of the very laws that govern existence. Ultimately, all of these questions lead to a humbling realization. There may be fundamental truths about the universe that we can never, ever know. In most sciences, an unanswered question is just a challenge waiting for a better tool or a cleverer experiment. But the cosmic horizon isn't a technological barrier. It's a physical one, imposed by the laws of nature itself. We are trapped inside our bubble of observation. But here's the beautiful paradox. This limitation is what makes cosmology so compelling. The edge of the observable universe is also the edge of human knowledge and the launch pad for our imagination. To explore what lies beyond, we must rely on the power of mathematics, theory, and pure human creativity. We're trying to map a territory we can never visit, guided only by logic and a deep-seated curiosity to understand our place in the grand scheme of things. So while we may never get a definitive answer, the quest to understand what lies beyond our cosmic horizon pushes us to ask the biggest questions possible. It forces us to confront the limits of what we know and dream about what might be. The universe might be infinite, part of a multiverse, or stranger than we can possibly imagine. We may never see it, but just knowing those possibilities exist is enough to fill anyone with a sense of wonder. For nearly all of human history, our world was capped by a dome. The sky above was a ceiling, the horizon a wall. Whether you stood on a mountain or sailed an ocean, you were always at the center of a finite circle, the known world. It was a comforting, if limited, view. Today, science has shattered that dome. We've pushed the horizon out, not by miles, but by light years. 46 billion of them, in every direction. Our known world is a sphere of unimaginable size, yet the ultimate irony remains. We are still inside a bubble, still confined by a horizon. This time, it's not geographical, but cosmic. This observable universe isn't just a mind-bending number for astronomers. It's a fundamental concept that shapes our entire understanding of reality. It dictates the maps we draw of the cosmos, challenges our sense of importance, and forces us to confront the limits of what we can ever know. So, how does this ultimate boundary define our existence? Let's start with our cosmic map. Think about any map ever made. It has edges, right? Coastline, a border, the end of the parchment. For cosmologists, the edge of their map is the observable universe. The ultimate boundary is something called the cosmic microwave background, or CMB. This is the oldest light in the universe, faint afterglow from the Big Bang. It's literally the edge of what we can see. A wall of light from a time when the universe was an opaque, hot soup. Beyond that wall, we have theories, but no direct evidence. Every grand model we have about dark matter, the expansion of the cosmos, its ultimate fate is built using data from within this sphere. We are like ancient cartographers, carefully sketching a world whose true extent remains forever beyond the horizon we can see. Now here's where it gets a little weird, psychologically. Since we can see 46 billion light years in every direction, it means we are, by definition, at the exact center of our own observable universe. It's a tempting thought, isn't it? That after all this time, we are the center of it all. A beautiful, profound illusion. An alien astronomer on a distant planet in the Andromeda Galaxy would also see themselves at the center of their own observable universe, a sphere that partially overlaps with ours. The cosmic horizon is a great humbler. It teaches us that our viewpoint is fundamentally local. We're not looking out from the VIP box of the cosmos. We're just one of a potentially infinite number of windows, each with its own limited view of the same grand, sprawling reality. The sheer scale of it all is difficult to wrap your head around. A radius of 46 billion light years, an estimated 2 trillion galaxies packed inside that volume. A number of stars so large it's practically meaningless, something like a 1 followed by 24 zeros. And yet every single thing humanity has ever done, every empire built and fallen, every song sung, every life lived has happened on one tiny, fragile planet. A speck of dust orbiting an ordinary star in a quiet suburb of the Milky Way galaxy. The cosmic horizon presents us with a powerful paradox. It's a space so vast it feels infinite, yet we know it has a boundary. It simultaneously shows us how breathtakingly small we are and how incredibly fortunate we are to even be aware of the cosmic ocean we inhabit. But this horizon isn't just a limitation. It's also our greatest laboratory. That wall of light I mentioned, the cosmic microwave background, isn't a dead end. It's a fossil record. By studying its faint temperature fluctuations, scientists have been able to measure the age of the universe with incredible precision, 13.8 billion years. They've figured out what it's made of, mostly mysterious dark energy. And dark matter, with only about 5% being the normal stuff that makes up stars, planets, and us. The CMB even shows us the tiny quantum seeds that grew into the vast clusters of galaxies we see today. In a strange way, the universe's limit is its greatest gift to science. It provides a perfect snapshot of the cosmos, as it was just 380,000 years after the beginning. Without that horizon, we'd be adrift, with no clues about our own cosmic origin story. This brings us to a deeper, more philosophical level. Cosmic horizon forces us to think about the nature of knowledge itself. It's a permanent reminder that our perception of reality will always be bounded. Our ancestors looked up and saw stars as fixed lights on a celestial sphere because that's what their horizon allowed them to perceive. We look out and see a sphere of galaxies 93 billion light-years across. But we too live inside a bubble we cannot see beyond. This raises some of the biggest questions we can ask. How much of reality is forever hidden from us, outside our observable patch? Can science ever truly create a theory of everything? Or will it always be a theory of everything we can see? Is the horizon a temporary scientific problem we might one day solve? Or is it a permanent philosophical boundary, an inherent limit to any mortal mind? These aren't just questions for scientists in labs. They are questions for every one of us who has ever looked up at the night sky and wondered. In the end, this cosmic boundary helps define our identity. It frames who and what we are. On one hand, it underscores our insignificance. In the face of 2 trillion galaxies, our planet isn't even a pale blue dot, as Carl Sagan so beautifully put it. It's an atom within that dot. But on the other hand, the horizon reveals something truly extraordinary about us. We are the part of the universe that has evolved the ability to look back and see it. We are stardust that can comprehend the stars. Our minds, confined to this tiny rock, can reach out across billions of light years and piece together the story of the cosmos. The horizon may confine our vision, but it doesn't confine our imagination. It sets the stage for the human drama, and it connects us to the greatest story ever told, the story of the universe itself. Have you ever looked up at the night sky and wondered where it all ends? What is the edge of everything we can see? The edge of the observable universe isn't just some abstract idea from a physics textbook. It's the grand finale of a story that spans centuries, a story of human curiosity, invention, and an unyielding desire to see what lies beyond the horizon. It's the journey from the first time someone looked through a simple lens to the most powerful. Telescopes peering back to the dawn of time. This is the story of how we reach the edge of our cosmic window. For most of human history, our universe was cozy and small. Everything we could see with our own eyes. The stars, the planets wandering across the sky, the ghostly glow of the Milky Way. That was it. That was the entire cosmos. Ancient civilizations built their worlds around this view. The Babylonians meticulously tracked the paths of planets. The Greeks drew beautiful maps of the stars, and scholars for centuries debated the nature of the celestial spheres holding it all together. Earth was at the center, and the heavens revolved around us. But then, in 1609, everything changed. An Italian astronomer named Galileo Galilei pointed a homemade telescope towards the sky. What he saw shattered the old world forever. He discovered moons orbiting Jupiter, proving that not everything revolved around Earth. He saw mountains and craters on our own moon, revealing it to be a world, not a perfect celestial orb. And he saw that the Milky Way was made of countless individual stars, too faint to be seen by the naked eye. In that moment, the universe didn't just get bigger, it cracked wide open. The dome of the sky had its first fissure, and humanity was just getting started. Fast forward to the early 20th century, telescopes had grown from Galileo's simple spyglass into colossal instruments of discovery. At the Mount Wilson Observatory in California, an astronomer named Edwin Hubble was using the magnificent 100-inch Hooker telescope. His mission was to study the faint, fuzzy patches of light then called spiral nebulae. At the time, no one knew for sure if they were just gas clouds within our own Milky Way or something else entirely. Hubble proved they were distant galaxies, island universes just like our own. But that wasn't even his most profound discovery. In 1929, he announced something that shook the foundations of cosmology. He found that these galaxies weren't just sitting still. They were all moving away from us. And the farther away a galaxy was, the faster it was receding. This wasn't just random motion. The entire fabric of space itself was stretching, carrying the galaxies along with it. The universe was expanding. This single observation meant the cosmos had a history. If it's expanding now, it must have been smaller in the past. It must have had a beginning. Crucially, it meant there was a horizon, a point in the distance so far away that the light from it hasn't had enough time to reach us yet. The edge of the observable universe was no longer a philosophical idea. It was now a scientific reality. The next great leap forward came not from an astronomer, but by complete accident. In 1965, two radio engineers at Bell Labs, Arno Penzias and Robert Wilson, were trying to get a new, highly sensitive horn antenna to work. They were plagued by a persistent, faint background hiss, like static, coming from every direction in the sky. It was there day and night, no matter where they pointed the antenna. They tried everything to get rid of it. They checked their equipment, rewired the connections, and even cleaned out what they politely called a white dielectric material, pigeon droppings from inside the horn. But the noise wouldn't go away. Frustrated, they eventually got in touch with a group of physicists at nearby Princeton University who had been theorizing, if the Big Bang really happened, there should be a faint afterglow of radiation left over, filling all of space. Penzias and Wilson had stumbled upon it. They had found the cosmic microwave background, or CMB. This wasn't just any light, it was the oldest light in the universe. It's an image of the cosmos when it was only 380,000 years old. The moment when the universe cooled enough for atoms to form and light to travel freely for the first time. The CMB is the ultimate baby picture of our universe. It defined the true physical edge of what we can see. We had finally reached the wall of light at the dawn of time, while ground-based telescopes took us far. They always had to contend with one major obstacle: Earth's atmosphere. It twinkles the stars, but it also blurs, distorts, and blocks huge portions of the light coming from space. The next logical step was to go above it. In 1990, NASA launched the Hubble Space Telescope into orbit. Freed from the blurring effects of the atmosphere, Hubble delivered images of breathtaking clarity and depth. It showed us galaxies billions of light years away, giving us a direct look into the cosmic past. Each image from Hubble was like a time machine. But to see the very edge, we needed to look at the cosmic microwave background with even greater precision. That's where missions like WMAP in 2001 and the Planck satellite in 2009 came in. They mapped the CMB in exquisite detail, measuring tiny temperature fluctuations, variations of just a few millionths of a degree. These tiny ripples were the seeds from which all the galaxies and cosmic structures we see today grew. And then, in 2021, came the next giant leap: the James Webb Space Telescope. With its enormous golden mirror and its ability to see in infrared light, JWST was designed to push past Hubble's limits. It can peer through cosmic dust and look back even further in time, to see the very first galaxies beginning to form just a couple 100 million years after the Big Bang. Each of these telescopes has acted as a stepping stone, carrying our vision and our understanding closer and closer to that ultimate beginning. What makes this entire journey so remarkable isn't just the incredible technology we've built. It's the human spirit behind it all. It's It's a story about refusing to accept the limits of what we can see. Each generation of scientists, engineers, and dreamers looked at the horizon of their time and decided to push it back. Galileo showed us the universe was far grander than the world contained within the celestial spheres. Hubble proved that this grand universe was not static, but growing, with a deep history. Penzias and Wilson accidentally discovered the echo of its creation. And the space telescopes of the modern era have allowed us to map that history in stunning detail, transforming the sky from a collection of mysterious lights into a detailed chronicle of cosmic evolution. Step by step, failure by failure, and discovery by discovery, we have taken the darkness and filled it with knowledge. We've drawn a map that stretches back 13.8 billion years, all the way to the edge of time itself. It's one of humanity's greatest intellectual adventures. And yet, after all this progress, after pushing the horizon back again and again, we've encountered a final, immovable wall. The observable universe, by its very definition, has a limit we can never cross. The universe is expanding, and because of that, there are regions of space receding from us faster than the speed of light. This isn't a violation of Einstein's theory. It's the fabric of space itself that's carrying them away. Light from those galaxies will never, ever reach us. No matter how powerful our telescopes become, no matter what new technologies we invent, those parts of the cosmos are forever beyond our view. This might be the ultimate lesson from our long journey to the edge. Human ingenuity is powerful. We can stretch our horizons, we can solve ancient mysteries, and we can see to the dawn of time. But we are also part of a universe with rules we cannot break. We are cosmic explorers, and it's in our nature to push boundaries. But we are explorers on an island, in a vast, perhaps infinite, cosmic ocean, with a horizon we can see but can never, ever reach.
Imagine standing at the very edge of everything we can see. On one side, you have the entire history of the cosmos laid out before you, 13.8 billion years of cosmic evolution, from the first stars to our own Milky Way galaxy. This is the observable universe, a sphere of light with Earth at its center, stretching 46.5 billion light-years in every direction. But on the other side of that edge, there's nothing. Not a void, but a profound, absolute silence. A region of space forever cut off from us. Its light unable to reach us because the universe itself is expanding faster than light can travel. This boundary is our cosmic horizon, and it forces us to ask one of the most fundamental questions imaginable. What lies beyond it? One of the longest-standing debates in cosmology is whether our universe is finite or infinite. If the universe is finite, then what we call the edge might be a true physical boundary, or more intriguingly, space could be curved, looping back on itself. In a universe like that, if you could travel in a straight line for long enough, you'd eventually end up right back where you started, much like circumnavigating the globe. It would be a cosmos without an edge, yet still finite in size. But what if the universe is infinite? If that's the case, our magnificent observable universe is nothing more than a tiny, insignificant bubble in a truly endless ocean of existence. Beyond our horizon, there would simply be more of everything, more galaxies, more stars, more planets, stretching on forever and ever. Current observations from telescopes like the Planck satellite suggest that the universe is spatially flat, which strongly hints at it being infinite. But because of our horizon, we can never be 100% certain. We're stuck inside our bubble, looking out, but we can't see the whole picture. But some theories push this idea even further into territory that sounds like pure science fiction. The theory of cosmic inflation suggests that in the very first fraction of a second after the Big Bang, the universe underwent an explosive exponential expansion. A popular extension of this idea is that our Big Bang wasn't a one-time event. Instead, it was just one of many, constantly creating new bubble universes in a vast, churning cosmic foam. This is the multiverse. In this scenario, our universe is just one bubble among an infinite number of others. Each of these bubbles could have its own unique set of physical laws. One might have stronger gravity, another might have different fundamental particles, and some might even have more or fewer dimensions than our own. If this is true, then beyond our horizon isn't just more space, but entirely different realities. The problem: the multiverse is the ultimate scientific paradox. By its very nature, these other universes are fundamentally unobservable, existing beyond our horizon and causally disconnected from us. It's a theory that could potentially explain everything about our own existence, but we may never be able to prove it's real. Now, here's a thought that's both profound and a little bit sad. The expansion of the universe isn't slowing down. It's accelerating, driven by a mysterious force we call dark energy. This means that galaxies we can see today are being pushed away from us at ever-increasing speeds. Eventually, one by one, they will cross our cosmic horizon and vanish from our sight forever. Billions of years from now, a future astronomer in the Milky Way will look up at the night sky and see almost nothing. All the distant galaxies will have receded beyond the horizon, leaving only our own local group of galaxies visible against a vast, dark, and empty void. For that future civilization, the universe will appear static and lonely. They would have no evidence of the Big Bang, no cosmic microwave background radiation to study, and no concept of an expanding cosmos filled with trillions of galaxies. They would be cosmically isolated. This realization makes our current era incredibly special. We live in a privileged moment in cosmic history, a time when the universe is still bursting with light and information. When the grand story of the cosmos is still visible for us to read. We are the witnesses to a universe in its glorious prime. So, the horizon isn't just a physical boundary out there in space. It's also a philosophical boundary right here in our minds. It forces us to confront the limits of science itself. Can science truly claim to understand a reality it can't observe? If most of the universe lies forever beyond our reach, does that mean our picture of reality will always be fundamentally incomplete? Are we doomed to spend our entire existence inside this cosmic bubble, never knowing the full story? For many scientists, this isn't a cause for despair. Instead, it's a powerful motivation for creativity. The edge of what's knowable is where the most exciting science happens. It pushes physics, mathematics, and our own imagination to their absolute limits, forcing us to devise new ways of thinking about reality itself. The horizon is a challenge, and humanity has always been at its best when faced with a challenge, and we are rising to that challenge. While we can't physically travel beyond the horizon, we are developing new tools that might allow us to peek behind the curtain. Gravitational wave astronomy, for instance, is a revolutionary new way to hear the universe. One day, it might detect faint ripples in space-time left over from the very first moments of the Big Bang, giving us clues about the conditions that existed before the universe became transparent to light. Neutrino telescopes, buried deep underground, are looking for ghost particles that travel unimpeded through matter, potentially carrying information from cosmic events that are invisible to our telescopes. In the far, far future, who knows what technologies our descendants might develop? They may discover ways to probe the fundamental structure of space-time that we can't even dream of today. We may never be able to directly see what's beyond the edge, but we might be able to infer its existence by studying its subtle fingerprints on the universe we can see. In the end, looking at the cosmic horizon is like looking into a mirror. It reflects not just the boundary of the physical universe, but the boundary of human knowledge. It forces us to confront our own limitations, but it also showcases our insatiable curiosity. Standing before this ultimate mystery, we have a choice. Do we accept that we can only see a small part of the cosmos and be content with that? Or do we continue to reach for what lies beyond, even if we know we can never fully grasp it? I think the answer is clear. The edge of the observable universe isn't an ending. It's not a wall stopping our progress. It is the beginning of the greatest mystery we have ever faced, and the human story has always been about running headfirst into the unknown. We live in a universe that is vast beyond measure, 46 billion light-years in every direction, and yet that is only the visible part. Beyond lies the unseen, the unreachable, the unimaginable. The horizon is not a wall. It is a reminder. A reminder that the cosmos will always be bigger than us. But it is also an invitation to keep looking, keep building, and keep asking. Because here, at the edge of reality, the human story is only just beginning. Thank you so much for watching. If you enjoyed this journey to the edge of space and time, don't forget to like this video and subscribe for more adventures into the cosmos. See you next time.